friends, welcome to the channel of Digital to Real. Today I will discuss about case statement in Verilog and case Z statement in Verilog. Now in Verilog there are 4 types of logic levels. Number 1 0 logic level, number 2 1 logic level, number 3 Z high impedance state logic level, number 4 is X unknown logic value. Unknown logic value means it can have the value of 0, 1, Z or transition. So in normal case statement, the case expression needs to exactly match for one of the case statement or items to execute. And there is no provision of don't care. See, for example, case. Here it is a concatenation operator, this curly bracket and inside A, B, C. So this case statement, and for this case statement, this one is the case expression between the brackets. Okay. And for case statement, I have an end case statement. So this ABC, okay, for ABC, they can have the value of, they can together have the value of 0002 111. 3-bit 9 combination. So, for different combination of ABC, I have put a output value of F. So, these 3 tick B 000, 3 tick B 001, these are called the case items. So, I have 8 case items and this is the output statement. So, when ABC is either, when the together ABC forms either of the cases of the case items, I will get the respective output. This is like a lookup table. Okay. But we can have a default statement here also. Means when ABC, either of them doesn't matches, means when the together 3 of them on concatenating do not match the value of this, all the 8 items, then what I will do, I will have a default case. Okay. I will have a default case. And default case, for default case, I will provide a default value of output. That means that if A is X, or A is Z, or B is X, B is Z, or C is X, or C is Z, then in that cases, I am not having an exact match here. So, I will move to the default value of output. Now we will see the case Z statement, which is an advanced form of case statement. Okay, case Z statement solve the problems by allowing don't care. So, what we saw for case statement, when we were concatenating ABC, we were not allowing the value of don't care state for A or B or C. Means if A or B or C were don't care, then we'll directly go to the default item, default case item of the case statement. Okay. Because we need an exact match. We needed exact match in the case of case statement. So, this case Z statement, what it is doing? This particular Verilog statement is allowing us to have Z, or Z can be put as question mark in the case expression. And the Z or question mark in the case expression can have match to 0, 1 or Z in case items. Now let us see an example. Let us see the usage of case Z statement in priority encoder. Okay. A priority encoder is used in the interrupt controller. And in interrupt controller, we use most critical out of the multiple interrupt requests. So this is the priority encoder. So we have multiple requests of interrupt. So depends upon the priority or the most critical one that would be picked up by the processor. This is the block diagram of the priority encoder. I have 4 inputs, A0, A1, A2, A3. and here are 3 output P0, P1, P2. The A0 input, it is of lowest priority. These inputs are nothing but the interrupt request. So A0 interrupt request is of lowest priority. A3 interrupt request is of highest priority. So I am writing a truth table for this priority encoder. So input is A3, A2, A1, A0. Outputs are P2, P1, P0. Please note, when A3, A2, A1, A0 all zeros, P2, P1, P0 is also all 0, 0, 0, 0. Now when the input is 0, 0, 0, 1, at that time P2, P1, P0 is 0, 0, 1. When inputs are 0, 0, 1, X means don't care. I am not bothered about what is there in A0, and A3 should be 0, A2 should be 0, and A1 is 1. At that time, output would be 0, 1, 0. Then the input is 0, 1, XX. That means A3 should be 0 in the input, A2 should be 1. But I am not bothered about A1 and A0 inputs. I don't care. Okay. So, 0, 1 and this 2 don't care. P2, P1, P0 at the output would be 0, 1, 1. Now these inputs, you see A3 to A0 is, A3 should be 1, but A2 to A2, A1, A0, don't care. They can take any value. P2, P1, P0 then would be 1, 0, 0. Now I am going to write the Verilog code of the priority encoder example using the Casez statement. Module priority encoder underscore case Z. Okay. Input wire 4 down to 1A. The input A is 4 down to 1. It is of 4 bits. Output reg 2 down to 0 P code. P code is the output. It is of 3 bits. Always a star means so whenever there is a change in the expression value of A, okay, we will go inside the always block. I will come across the case ZA statement. Now, A is if it is 4 tick B 1 triple Z semicolon, P code is 3 tick B 100 semicolon. Okay, you see with respect to the truth table, you see 4 tick B 1 Z Z Z. Though I have put here the don't care value can be 0, 1 or Z. 0, 1 or Z. 3 possibilities are there. So, when the case Z statement A is, the expression is 4 tick B 1 triple Z semicolon triple Z, I will have this P code as 100, 3 tick B 100 semicolon. When the expression A have the value of 4 tick B 01 ZZ, P code value would be 3 tick B 011 semicolon. When I will have the A expression as 4 tick B 001Z, I will have the P code as 3 tick B 010 semicolon. When the expression KA will have 4 tick B 0001, P code will have the value 3 tick B 001. Okay, so from the truth table I have written the case statement case Z. Now when the A is 4 tick B all zeros, then P code would be 3 tick B all zeros semicolon end case for the case statement and module for the module statement. Now note the statement. Please note the statement 4 tick B 1 triple Z semicolon. So this was the statement case item. For that P code value is 3 tick B 100 semicolon. It means that we don't care. We actually don't care. If the bits 2 down to 0 means it is a 4 bit, no, 0, 1, 2, 3. Okay, 0, 1, 2, 3. So 2 down to 0, 2, 1, 0, 3. So this and this. 2, 1, 0. 3 bits. 2 down to 0 are 0, 1 or Z. Okay. And the above statement would also be written as, you can write it as this way also. 4 tick B 1. Instead of Z, 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 I can put it at question mark, question mark, question mark. It also means the same only. So P code is equal to 3 tick B 100 semicolon. Please note that all the codes are pseudo code. They are not actual codes. As we have seen the priority encoder design module, now we will see the Testbench module. So please find below the Testbench of the code and we will verify how it works. So tick time scale 1 nanosecond by 1 picosecond, module stimulus semicolon. Reg 4 down to 1A. So input is made here as reg 4 down to 1A semicolon. Wire 2 down to 0 opcode semicolon. Output is put as wire here. Now I will instantiate the DUT. So priority underscore encoder underscore Casez UUT is the instance name. Instance name, I have connected the port here, input and output dot A bracket A semicolon dot P code connected to P code bracket close semicolon. Now initial begin. Initialize the input. A is equal to 4 tick B all 4 zeros semicolon. Hash 20 means after 20 time unit, A is equal to 4 tick B 0 B 0001 semicolon. So A is a 4 bit. So I am having 16 combinations. So all the 16 combination of input I have provided with a span of 20 time units. Means after 20 time units, again hash 20, A is equal to 4 tick B 0010. After 20 time units, A is equal to 4 tick B 0011. So in this way I have provided till this point. Hash 20, A is equal to 4 tick B all 1 semicolon, then hash 40 semicolon, then end. For this initial begin end, I have the end over here. Okay. So this Testbench code is written with for this particularly priority encoder Casez, where case Z statement we're having the input of expression A. Okay. And you see for 0001 means 0001, that is equal to 0001. So P code would come as 3 tick B 001 semicolon. 0010 P code value will come as 3 tick B 010. Then A 0011 0011. Okay, P code will come as 3 tick B 010 semicolon. So in this way we can see, when if we run it, we will see the log file and we can find that for the respective A value what is the P code value coming at the output. Inside the module stimulus, I have provided another initial begin end block where $monitor statement has been put. So inside the $monitor statement, inside the double quote, T is equal to %3D, comma A is equal to %4B, comma P code is equal to %3B. Okay, and T here these are the format string. Okay, and for T it is actually system task $time will be called. A is the expression, case expression that would be displayed, and P code, it is of 4 bits and P code is of 3 bits. All will be displayed in binary form. Whenever the $time A and P code changes, $monitor system task will be called and a display C statement will be put in the output screen. And here is the end module for the stimulus state module. Now we will see another example of the Casez, okay, for a multiplexer. So this is a 4-cross 1 multiplexer. A0 3 down to 0, A1 3 down to 0, A2 3 down to 0, A3 3 down to 0. These are the 4 inputs and output is out 3 down to 0 semicolon. And 2 select lines are there. Okay, S1 and S0 to select 4 inputs and provide it to the output. Mux example showing the usage of case Z. So it is a Mux example module which we will see how the case Z statement is used. Module Mux 4 down to 1. Select SEL select comma A0 comma A1 comma A2 comma A3 comma out bracket close semicolon. Input 2 down to 0 is SEL select semicolon. Input 3 down to 0 is A0, A1, A2, A3 semicolon. Please note, select is actually 2 bits only. 1 down to 0 in order to select 4 inputs. But still I have provided in the input extra bit for SEL select. So it is 2 down to 0. Output is of reg type 3 down to 0 out semicolon. So always at the rate of SEL select or A0 or A1 or A2 or A3 begin. Case Z SEL select 3 tick B 000. For this case item output is A0 semicolon. 3 tick B 001 output is A1 semicolon. 3 tick B 010 output is A2 semicolon. 3 tick B 011 output is A3 semicolon. 3 tick B 1 then 2 question mark. That means this 2 bit position can be 0, 1 or Z. Our output is 4 tick B all zeros semicolon. Means whenever this most significant bit of the select would be 1, irrespective of the value of other 2 bits, output would be 4 tick B all zeros. Okay, end case for this case Z statement, end for this begin statement, and end module for this module mux 4 to 1. Please note, if the MSB select bit is 1, the output is forced to 0 no matter what. Another thing we have to note is that when there are more than one match, in case Z statement, the first match takes effect. The first match takes effect. We will show actually. For example, module case Z underscore priority semicolon. So this is a module definition. Inside the module reg select semicolon is there. So always at select, whenever the select changes, we will go inside the always block. And inside the always block, I have case Z statement. So case Z inside the bracket select. Select is the expression, case expression. Now, this select, the case expression can have 3 values 0, 1, Z. So 1 tick BZ is $display. For 1 tick BZ, when it is the case item, $display is what? KZ colon logic Z on select. Inside the double quotes I have put because it is a display statement. Whenever the case item is 1 tick B1, $display is put as KZ logic 1 on select. Whenever the select is 1 tick B0, $display KZ is logic 0 on select. I have end case for the case statement. Now initial begin end. #1 $display driving 0 semicolon. Select is equal to 1 tick B0 semicolon. #1 $display driving 1 semicolon. Select 1 tick B1 semicolon. #1 is $display driving Z semicolon. Select is equal to 1 tick BZ semicolon. Then #1 $finish semicolon end. For this begin, I have an end. So inside both the initial, always an initial blocks, no, they will start at the same point of time only. Okay, they are procedural block, they will start at the same point of time. Please note, this module I have written in order to prove what? The statement when there are more than one match, the first match takes effect. So in order to prove that, I have provided the module and end module. So from the initial block, if you see, the first I have provided the input 1 tick B0 semicolon. And second input of select I have provided 1 tick B1 semicolon. And the third input I have provided is 1 tick BZ semicolon. Now, when 1 tick B0 semicolon is provided, no, at that time, if we go inside the case Z statement, please note the select one tick B Z will get selected and one tick B 0 will get selected because Z can take the value of 0, 1 or Z. So this one tick B Z is coming before one tick B 0. So the first match, there are two matches. For this select one tick B 0, there are two matches. So first match will take effect. So the display statement would be KZ logic Z on select. Now when the select is equal to one tick B1, so we are driving 1. Already I made first the display of driving 1 and then I am actually driving the select value one tick B1 in the initial begin and block. Now see, driving 1. So here there are select will have two matches again, one tick BZ, one tick B1. First match will take effect. So display would be $display KZ logic Z on select. This particular statement KZ logic 1 on select, it won't come into effect. What comes into effect is the first match KZ logic Z on select. Now inside the initial begin and $display driving Z. First of all I made the display driving Z, then select is equal to one tick BZ semicolon. Here you see, here I have put the Z input. So Z input will directly match with the value one tick BZ. Okay. And the display would be KZ logic Z on select. So please note, for all the three cases when select is 0, 1 or Z, first statement, that is the first match in the case block, is coming into effect, is taking effect and match is found. So the logic would, the output would have the following thing: driving 0 KZ logic Z on select, driving 1 KZ logic Z on select, driving Z KZ logic Z on select. So the reason is that is the first statement, that is one tick BZ $display KZ logic Z on select. This is equivalent to one tick B question mark $display KZ logic Z on select. So these two statements are same. So if you like this video on KZ statement, share it with your friends. Please subscribe the channel and have a very nice day. Bye bye.